Assalamu alaikum and welcome to a revision video for the writing questions. Before I get started, I just wanted to say thank you to teacher Miss Maryam Al-Ghaithi, and she teaches at Al Ma'ali School, for making such a wonderful resource to help you guys prepare for writing portion of this exam. Okay, so the first outcome under the writing is to assign magnetic poles according to repulsion and attraction forces, and explain why any piece of a magnet will be a smaller magnet with two poles. Assign magnetic strength and label it on magnetic fields, and using a compass needle, assign the direction of magnetic fields. And here are the pages in your textbook. So, here, this first question is asking us to draw the field lines from the magnet. So, field lines will also always go on the magnet from north to the south end. So, I'll just draw a couple here, and then they will come all around the magnet here, and I'll do the same on this side. Then do one from here, and remember the direction is from north to south. So I will draw my little arrows on here. We could draw a couple of field lines coming out this way. And going in. That was an accident to be so far out from here and here. Okay. Remember that north is always attracted to south. And then we have repulsion forces. So repulsion forces, or repel, means to push away when we have south to south or north to north. So the question here says, when you break an iron magnet into two pieces, what will you get? So, and why? So if we break a magnet, we'll form two new magnets with north and south poles, respectively. Let's make this bold and change the color. So we'll get two new magnets with north and south poles, because the magnetic domains, which we spoke about in the first video, will realign. And if that word is too challenging for you, we can write line up again. So realign just means to line up again. So the picture shows a bar magnet with the poles labeled north and south. In this example, here we have north, and then a question mark is there. So we would want to change to a pen. That question mark will actually be, and let me use blue since south is always blue, will be south on this end. And here, this would be north. Okay, and here's the reason. A broken magnet will form two new magnets, each with their own north and south poles. So in this question, it's telling us to assign magnetic strength and label it on the magnetic fields. We know that the north pole and the south pole are the strongest part of the magnet. So the weakest part, and we tested this in class, is the middle. Remember, you couldn't get a paper clip to stick to the middle part, so the strongest part is north and south, and the weak part, oh, let's change to writing. Okay, so this one says, using a compass needle, find the direction of the magnetic field. Here, the picture's been drawn for us, but let's go ahead and label. If this is south, that means the north part of the compass is going to be facing the south, and this side is north. So that means the south side of the compass is pointing towards, so south is going to point towards your north, and your north will point towards your south. Okay? Okay, next question, it says to explain how matter and charged particles interact, define repulsion and attraction, electrical forces and electric fields, explain what factors affect the current, and draw a simple electric circuit. So I'm just going to go through these quickly, and then if you have questions, you can message me. Why does a balloon attract water? The water and balloon simply have opposite charges. We're not 100% sure which one has a negative charge or a positive charge, but we know that they are opposite charges. The water balloon have opposite charges because opposites attract. We know whether we're talking about electricity or we're talking about magnets, that opposites attract, I'm sorry. So define electric forces. Electric force is a non-contact force. An object has, because positive, I'm going to use a symbol, or negative charges on the object. And we know these forces can be repulsive or pushing force, or attractive, which is the pulling force. An electric field is an area around a charged object that can apply a force on another object. And again, I'm just going through this a little bit quick, but again, if you have questions, you can send me a message, and I will have a meeting before your exam. We know that B is negative. They give us that information. So that means A is positive. I'm going to use a symbol so I have space to write. It's attracted. It attracts B. That's how we know. Here, C is negative. It repels B, which means they have to be the same. So opposites attract, so A has to be positive in order to attract B in this picture. Same, similar, repels, so C has to be negative. Notice in case 2, it is a different picture. B is still negative, but A is attracted to B, so we know that A is positive. It attracts B. But in the second picture, we have A is repelling C. So C is positive. It repels A. So notice that in each picture, C is being interacted with different objects. So let's look at what factors can affect an electric current. We know voltage or strength of the electric charge can, somebody in class mentioned coils in the wire. Can affect an electric current. And there was something else. Oh, type of conductor. Can also, so copper is a good conductor, we learned in the book. But we can use other things as conductors, such as aluminum or other metals we could use as conductors, but copper is a good conductor, so most wires are made of copper. Let's draw a simple circuit. First, let's list the parts of a circuit. One, we know we need energy. We know we need a conductor. And we also need a device. And lastly, we can utilize a switch. So I will go ahead and draw a picture. Let's start with our energy source, which in this case is a battery. Then I will draw my conductor, which is going to be my copper wires. I will add a device. I should have made this yellow. I'm going to continue with my conductor, and I'm going to add a switch. And finish off my conductor to the other end of my energy source. Okay, and remember the function of each of these, where the conductor allows for the current to flow through it. Our device is going to be our light bulb that will be turned on and off. Our switch allows us to turn off and on our light bulb, and then we have a battery, and we can use we can go ahead and write 3 volts in there. You're using the 3-volt battery here. Okay, so let's look at some of the differences between mechanical waves. So mechanical waves require a medium or matter, or we can even write solid, liquid, gas. So they require a medium. We have 2 types. We have transverse and longitudinal waves. And then we have our examples of sound waves and water waves. And then we have our electromagnetic waves. Change colors. Electromagnetic waves can travel through a vacuum. Slower through a medium, through a dense material. Our examples are light, X-rays, microwaves, gamma rays. I mean, there's all kinds of examples that we can use. UV light. We went through different examples in class. What else do we know about light waves? Okay, so some similarities. They all have amplitude. They all have frequency. They all are associated with energy. They all have a wavelength. What else? Amplitude, frequency, energy, wavelength, I think are three good measures of each. Remember, amplitude, we measure mechanical waves. Amplitude is related to its energy. Electromagnetic waves, frequency is related to its energy. Remember, wavelength and frequency have an inversely proportional relationship. I'm trying to think of what else might be useful. Here's some pictures of your mechanical wave. Here's your electromagnetic wave. We have our transverse wave. These arrows represent the amplitude. Okay, and we went over that in, I think, video number 2 or 3. Okay, here, it says, describes how waves interact with matter. And draw a model to represent the interaction. Explain how the human eyes see color. So we have a couple of things going on here. Reflection is when a wave bounces off a medium or an object, let's say. Absorption. Energy is transferred from a wave to a medium. Transmission. A wave travels through an object. And diffraction is when a wave changes direction around an object. Okay, so let's draw some models here. Okay, reflection is very easy. So we draw our line down. We know reflection's in the cusp, it's bouncing off. Okay, absorption is a little more complicated. So I'm going to draw my barrier there, and my wave is traveling through and absorbed by the barrier, so it doesn't go through that barrier. Let me go ahead and do transmission. Here's my barrier. My wave is traveling through and it passes through. So if we're talking about light, light is transmitted through transparent objects. Okay, and the last one, which I think is the most complicated for me to draw, and again, I will add this diffraction video to my list of videos, but here we have our wave and traveling through, and it will change size as it passes through, change directions as it passes through. And I'll share the video to show diffraction in water waves, but remember, diffraction also happens in sound waves. I can hear people down the hallway because that sound is traveling and bending and turning into rooms. Okay, explain how the human eye sees color objects, the color of objects. Okay, so this explanation can get pretty long, so I'll do it in parts. So first, white light white light has many colors. An object will absorb some wavelengths and reflect others. This apple reflects red and absorbs all other colors. Our cones on the retina will send the signals to the brain to interpret the colors we see. It's hard to see the typing. I hope this makes sense. So I will go ahead and explain this. We know that white light has many colors. It has all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. So that white light comes into this apple, and orange, yellow, green, blue, and violet are going to be absorbed. They're yamtas. And then the red color is what's going to be reflected. So red gets reflected by the apple and what enters our eyes. So the wavelength of red will enter our eyes, be detected by the cones that are at the back of our retina, and then our retina will send a signal to our brain and interpret that color and tell us what color that we see. What we need to know here is that black absorbs all colors of the light spectrum, so red, orange, yellow, blue, green, indigo, and violet. If it's a color, the color we see is being reflected. In this case, that color is red. And white is reflecting all colors of the spectrum. Okay? So, next question is asking, how do colors filters change the color of an object? Color filters let only select colors pass, or wavelengths of light pass. So the object will either reflect, absorb, or transmit the color that is being filtered through. So here in the picture below, the apple will reflect the red and absorb the green and blue. So the apple will appear black with green and blue color filters. I hope this is clear. And again, I will have a meeting with you guys, so if you have any questions on this, you can ask. But the apple will reflect the red, and that's why the apple will look red here. But green and blue are going to be colors that are absorbed of the color spectrum. So here, with the color filter, that area would appear black. Compare between concave and convex lenses and draw the pathway of the light rays passing through a lens. Okay, so concave lens curves inward. Lights will converge or come together. Real or virtual images can be formed by our, no, concave lens. I'm doing this backwards. Curves inwards, it diverges light. Which means it spreads apart. Sorry, please forgive my mistake there. Again, getting our mirrors and lenses mixed up a little bit. So our mirror will curve inward. Our lens will curve inward. So here's our optical axis coming straight through the middle. Any light that is parallel to that optical axis will diverge. So in this case, it's going to bend away from the normal as it passes through the concave lens. Again, it can get a little bit confusing when we're talking about lenses and mirrors. So now we're looking at our convex lens, which curves outward. I'm going to change the color here. Lights will converge, as I said before, come together. Our images here can be real or virtual. And when we draw our picture, optical axis goes through the middle. Sorry for my not so straight lines. Lines that are traveling parallel will converge at the focal point. Here's our focal point. Remember, this middle line here is your optical axis. And we also have our optical axis here as well. Okay, so that brings us to the end of this video. Again, I'll add videos about concave and convex lenses to the list of videos. Hopefully you find this helpful. If you have any questions, you can always send me a message or see you on Sunday in our meeting. Masalam.